Talk Radio.
Your number one news and talk station. The Midday Report with Stephen Curtis.
27 after 12 in the journal Nature Climate Change, a paper suggesting that international flights are going to get bumpier because of increased turbulence caused by climate change. Dr. Paul Williams is the author of the paper. He is a research fellow in the Department of Meteorology and at the National Centre for Atmospheric Science at Reading University. He's on the line now from Vienna, where he's been presenting that paper. Dr. Williams, good day to you. Thank you very much indeed for your time. What is the link between warmer temperatures, climate change if you like, and turbulence?
Good afternoon, Stephen. Well, climate change is certainly warming the lower part of the atmosphere where we live, but what not many people realise is that climate change is also changing the basic state of the atmosphere 10 kilometres above our heads where planes fly. And in particular, climate change is speeding up the jet stream, making it flow faster. And that is making the atmosphere more susceptible to the instability that causes turbulence to form.
How much is it speeding it up by? Is it possible to actually work that figure out at this stage?
Well, different computer models would give you slightly different predictions for the future of the jet stream, but it's a few percent. So it's speeding up roughly by a few percent, but whether it was 1% or 5% would depend on which computer model you looked at.
Is there likely to be a long process to this? We might find that it only increases by a percentage every now and then, but suddenly in, say, 50 years' time, there's actually a very big difference.
Well, certainly we would not expect it to go up uniformly in time. The jet stream varies a lot, not only in strength but also in position. And in fact, much of the weather we've been having in many parts of the Northern Hemisphere over the past few weeks and months has been because of jet stream effects varying. So I don't think we'll see a uniform increase, but certainly by the middle of this century, the study we're publishing today is talking about a doubling of the amount of transatlantic airspace containing significant turbulence because of the jet stream speeding up and changing its position.
Your research focused on transatlantic flights. The route between Europe and North America, of course, is one of the busiest in the world. Is it likely to be more affected than other areas, or could we find that other areas that perhaps don't receive as much attention could actually start to have more extreme behavior at those upper levels of the atmosphere?
Yeah. Well, as you say, we focused on the North Atlantic because it's a busy part of airspace. In fact, there are 600 transatlantic crossings every day, 300 westbound and 300 eastbound. But we would, of course, like in future to extend this work to other parts of the globe, wherever the atmospheric winds 10 kilometres up change, whether it's because of climate change or natural variability, then you would expect to see, as a consequence, the amount of turbulence change as well. So there's a lot more work to be done on this, but we're publishing today the first study to look at it in the Atlantic, and we hope to extend it in future.
That's Dr. Paul Williams, Research Fellow in the Department of Meteorology and the National Centre for Atmospheric Science at Reading University, on the line to us from Vienna.
The Midday Report.